Hi folks, welcome to 2022 and I hope you're all doing well. Today I want to take a look at a paper which describes a new sandboxing framework that the folks over at Firefox have been using. The problem that the authors are trying to solve over here is that when you look at a huge piece of software like the Firefox browser, it uses a large number of third-party libraries. For example, a library to read and display JPEG images. And we want to structure the code and the security model such that bugs in those third-party libraries cannot be exploited. So when we interact with these third-party libraries, we want to sandbox them so that they can do only the task that they're supposed to do. Going back to the JPEG example, when we use the JPEG library, it should have only access to the image that it's decoding and the image that it is producing or displaying. And that is the only access it should have. Now, most modern browsers like Firefox or even Chrome already have some level of in-process sandboxing. For example, each tab is sandboxed so that if one tab goes awry, it doesn't take down your entire browser process. But this goes a step further. Even if you isolate each tab, an attacker could still exploit bugs in third-party libraries to perform unsafe actions within that tab itself. So what the authors want to do over here is have finer grained protection that goes beyond the existing isolation that browsers already have. And this is a significant problem worth tackling because browsers rely on tons of third-party libraries to decode a whole range of content, things like audio, images, and fonts. To take a concrete example, if you look at this code snippet over here, which is trying to decode a JPEG, you look at this input parameter, which is part of the JPEG data. If you don't sanitize this appropriately, you end up using it in all these other places. For example, over here on line 5, or even with the mem move over here on line 16, you could read and write arbitrary memory within your process if you don't appropriately sanitize this input JPEG data. And this is just a small example, but this kind of issue is widespread in large code bases, and these are exactly the kinds of mistakes that end up getting exploited by attackers. So let's look at the solution that the authors are proposing. They call it RLBox, and it is a C++ library which makes it easier for developers to retrofit sandboxing when interacting with untrusted third-party libraries. The central idea behind RLBox is to utilize the C++ type system and use what it calls tainted types to tag untrusted data. So anytime you have data that originates from an untrusted source, you're gonna type it with a tainted type. And you can operate on tainted types, but you just can't do unsafe actions with those values that have tainted types. For example, if you have two tainted ints, you can add them or do arithmetic on them, but you can't branch on them, and you certainly can't use them as indices into an array. Tainted types can go through a validation process to make them untainted, and then you can do further computation with them. This basic idea of tagging untrusted data with a taint marker is actually a pretty old one. If you've been developing web applications for a while, you'll remember that back in the days of CGI and Perl, the Perl interpreter had a taint mode where it would mark all untrusted input as tainted, and then you would have to explicitly validate it before being allowed to use it in your application logic. The benefit of doing something similar in a strongly typed language like C++ is that when you mark something with a tainted type, the compiler will automatically tell you all the places where you then have to untaint or validate it. Fortunately, the authors found that these validators tend to be pretty simple. I'd imagine that most validators do simple bounds checks. So yes, this approach does require pretty extensive changes to your code base. And in a huge code base like Firefox, you want to be able to do that in an incremental fashion. And they do allow that. On the way to migrating your code base, you can disable some of these validation checks. And so you can incrementally change all these boundaries where you're calling out to untrusted libraries. And then when you're done, you can turn on your full sandbox. But while you're incrementally migrating your code base, it'll still compile and run. And this has been shipping in Firefox, but the authors have made RLBox available separately and hope that it will get used by other projects as well. So that was a quick look at RLBox, which is a sandboxing mechanism based on C++ types, which allows you to sandbox your interactions with untrusted third-party libraries. I hope you enjoyed that, and I will see you next time. Thank you very much.